Hi there guys, welcome back to another video. So today I'm going to be talking about pulse width modulation. So basically pulse width modulation is basically how long something is on for and how long it's actually off for. I've put a few diagrams here for you to have a look at, which is based off the duty cycle of a certain component, whether it's a sensor or a motor or even a light bulb as well. So pulse width modulation, as I said before, it does allow you to see how long something is off for and how long it's on for, but it also allows you to control that as well as if we were to look at either a motor or even a LED light bulb, it can also allow you to control the brightness of that or even the speed of a motor as well. So I'm just going to quickly go over this little diagram that I've got here. So as you can see, it is a diagram of each pulse width that is being generated. Judging by how many volts it is going up to, I will suggest this will be a diagram from a sensor, whether it's an ABS sensor or a cam or crank sensor, because quite often when you are looking at sensors around a certain vehicle, most sensors do operate within 5 volts. So I'm going to start with the top one here. So it says 0% duty cycle, which means it's completely off. And as you can see from the line just there, it is operating at 0 volts, which would indicate it is off. So with the 25% duty cycle, it's going to be on for 25% of the time, and then 75% off on the other times. So it's quite self-explanatory on what that means. Again, with the 50%, 75%, and 100%. So it just shows you how long it is on for compared to how long it is off for. Okay, so the signal that is being generated and also the pulse that is being generated is known as a square wave. The reason for that is because of the shape that is being produced by it. And quite often as well with square waves, it would actually be a digital signal that's being created from any of the sensors around the vehicle. And the reason for that is because with the ABS sensor, if we were to have a look at an ABS sensor, if it had a IC chip, it would generate a digital signal, which means it will be more accurate and it is a lot more effective in terms of how fast it does work. And it also, in terms of the accuracy as well, that will then come into, again, the pulse width modulation signal that you can see. So it's more accurate, you can see exactly where about roughly it's going to be working at compared to where it's going to be working at in terms of voltage at a certain time. So I'm just going to be moving on to the next slide now. So the type of equipment that you will be using to measure these signals will be a picoscope. I'll put a little diagram just there, just so you can see what they do look like. Certain picoscopes do look different depending on how much you want to spend and what it is that you need it for. This right here is actually a 4-channel picoscope because it's got a channel A, B, C and D. I believe that may be the power input. I'm not too sure what they are, but they are the channels right there, which you can see in the blue, red, green and yellow. And that's just basically just so you can monitor 4 items at a time, more or less. Just so if you do want to measure them across each other, you can do that if you like. And just right here, I've got another diagram of a square wave and a sine wave. The main difference between each of them is obviously how they do look across a picoscope reading, and also as I did say before as well, the square wave. It is quite often that the sensor that is being registered through the picoscope would actually have IC chip, whereas with a sine wave, there's a good chance that you're not going to actually have an IC chip in that sensor. Okay guys, so for the final part of this video, I'm just going to be going through the sort of pulse that you would see if you were reading an injector pulse. So as you can see here, you can see the current is going through, and just here you'll be able to see it just drop down to 0 volts. But then as it does go along through time, it does tend to go back up again, and you'll be able to see it does kind of go for a certain amount of duration as soon as it does go back up. So then as soon as it does go back down again, you can then see just here there is like a little ripple in the pulse. So that will basically indicate the spring mechanism that is inside of the injector. It will show you that it is working. So if you are if you are using any sort of picoscope or any sort of diagnostic equipment to see if the injectors are at false, a picoscope would be the best option to go with in terms of any sort of diagnostic equipment, because you can visually see the operation of any component within a vehicle. So yeah, if that little ripple wasn't there, it would indicate that the injector isn't working. So you would indeed need to then replace that injector for a new one. Yeah, I thought I'll just quickly show you that little bit there as well, and just so you know what sort of things to look for. But yeah, I hope you enjoyed anyway, and yeah, don't forget to subscribe and hit the bell icon, just so you are notified when I do upload another video.